Alright, today we're talking about linear function patterns, and your essential question is, can you use a linear function to describe a linear pattern? Your first question is, what is a linear function? It's just a function that forms a line. So we're going to continue to talk about equations of lines, but we're also going to talk about functions. Functions and equations of lines, often very similar. An equation of a line can always be written as a function. So you'll hear those terms used interchangeably. Use the graph to write a linear function that relates y to x. So essentially, all that's asking is you to write an equation of a line in slope-intercept form, which is y equals mx plus b. We can see that our intercept, our y-intercept is 0, and our slope is going up 3 over 1. So y equals 3x would be the equation of the line if you had the plus 0 in there for the y-intercept. That's not wrong, however, it looks better not to have it. On the next one, again, we want y equals mx plus b. On this one, my y-intercept is at 2, and my slope is going up 0 over 1. So 0 over 1x would just be 0. So our equation is y equals 2. Alright, use the table to write a linear function. So we could graph them all, each of our points. So 0, 150 be here, 2, 125, 4, 100, 6, 75, and 8, 50. So I'm going to write an equation of a line. I know my y-intercept is positive 150. And then I'm going down 25. So that's negative 25 over 2x plus 150. Alright, go ahead and try the next table for homework. And we'll take a look at the back page. Graph the data in the table. Is the domain discrete or continuous? Write a linear function that relates y to x. How many calories do you burn in 4.5 hours? Alright, so we first have to make a graph. And we also need to know how to label our graph. So for hours, we can just go by ones up to 8. And for calories burned, however, it looks like we might have to do something a little bit different. So I would say maybe I'm going to increase by 300s. Maybe that wasn't enough. Well, it's 1,500. That top one is going to be 2,400. Okay, so after 2 hours, we burned 600 calories. After 4 hours, 1,200 calories. 6 hours, and so on. How many calories do we burn in 4.5 hours? So that would be right here. 4.5 hours is going to be right here in the middle of 4 and 5. I would say around 900 calories. And the linear function that relates y to x, for every, we're going up 600 over 2. So 600 over 2 would reduce down to 300. So y equals 300x, and it's going through 0, 0, because if you don't kayak at all, you're not going to burn any calories. And we don't want to write that 0, but we just know that it's there. Alright. Write your linear equations for 1, 2, and 3. You should be able to do all 3 of those questions for homework. Yeah, 3A, B, and C you should be able to do for homework. Have a great night.